Have you ever wondered how something like Netflix or Spotify just works all the time for millions of people at once without a single hiccup? Well, a huge part of that magic comes down to a technology called Kubernetes. It's kind of like the invisible engine that powers a massive chunk of the internet. And today, we're going to pop the hood and see exactly how it works. So we know it came from Google. We know it's a big deal. The biggest apps in the world rely on it. But that still leaves the big question, right? What does it actually do? What's the problem it's trying to solve? That's exactly what we're here to figure out. And here it is in a nutshell. At its heart, Kubernetes is all about making your applications resilient and totally automated. The best way to think about it, it's like having a brilliant, tireless robot as your system administrator. Imagine you're running a website and it's Black Friday. Traffic goes through the roof. Without Kubernetes, you'd be sweating, watching your servers melt. But with this robot on the job, it sees the surge, instantly creates more copies of your app to handle the load, and keeps everything running smoothly. No drama, no downtime. Okay, let's start with its official job title. If you hang around developers, you're going to hear Kubernetes called this all the time, a container orchestrator. I know, that sounds like a mouthful, but the core idea is actually pretty simple. You've got your applications neatly packed up into little boxes called containers, like a Docker container, for example. Well, Kubernetes is the master conductor of the whole orchestra. It tells all those little containers where to go, how many of them should be running, and how they should all talk to each other. It takes care of all the messy logistics, so you don't have to. So, to do all this incredible work, Kubernetes groups a bunch of computers together into what's called a cluster. And honestly, the best way to wrap your head around this is to think of the cluster as a bustling city built just for your applications. We're going to use this city analogy to guide us through the rest of this. In our application city, you've got two main districts. First, you have the control plane. This is City Hall. It's the brain of the whole operation, making all the big decisions and sending out orders. Then you have the worker nodes. Think of these as all the buildings in the city. The factories, the offices, the apartment complexes. This is where your applications actually live and do their work. So, what's inside one of these buildings? Well, every worker node has a few key components. There's the kubelet, which is kind of like the building's superintendent. It gets its orders from City Hall and makes sure everything's running as it should. Then you have kubeproxy, which is like the building's mailroom and switchboard operator. It routes all the network traffic. The container runtime is the building's power grid, the engine that actually runs the containers. And finally, you have pods. These are the individual apartments where your application code really lives. And that brings us to the most basic fundamental building block in all of Kubernetes, the pod. But here's the absolute most important thing to understand about them. Pods are ephemeral. They are designed to be temporary. Now, that might sound crazy, right? Why would I want my app's apartment to be temporary? Because this is the secret to Kubernetes' self-healing powers. If a pod has a problem or crashes, Kubernetes doesn't waste time trying to fix it. It just gets rid of it and spins up a brand new, perfect replacement instantly. That's the key to everything. Okay, so we've seen the buildings where the work gets done. Now let's take a trip downtown and peek inside City Hall. What's really going on inside the brain of our Kubernetes city? It really boils down to four key players. Let's just walk through it. Say you want to launch a new app. First, you talk to the API server. That's the front door, the main reception desk of City Hall. The API server then writes down your request in etcd, which is the city's official book of records. It's the ultimate source of truth. Then the scheduler, think of it as the city planner, sees this new request and says, where should this go? It finds the perfect worker node, the perfect building for your app. And finally, you have the controller manager. This is the city's army of watchdogs, constantly patrolling and making sure that what's actually happening in the city matches the plan in the record book. All right, so we've got our cluster, we know the pieces. But in the real world, we don't just want to run one single temporary pod. We need a real, robust application that can survive anything. So how does Kubernetes do that? This is where we meet the deployment. A pod, like we said, is just a single apartment. It's mortal. If a fire starts, it's gone. A deployment, on the other hand, is the building's property manager. You tell the manager, hey, I need 3 apartments running my app 24/7, no matter what. If one of those apartments, one of those pods, fails, the deployment doesn't even blink. It just instantly creates a new one to take its place. It's the deployment's job to make sure you always have the right number of pods running. And this right here is why everyone loves Kubernetes for production. It gets rid of all that mind-numbing manual work that teams used to do. We call it operational toil.
Logging into servers late at night to restart a crashed app or manually adding servers during a traffic spike. Kubernetes just handles it. It frees up humans to do what they do best, build cool stuff.
Okay, this is great. Our app is self-healing, it's running like a champ. But there's a new problem. If our apartments, the pods, are constantly being created and destroyed, how does anyone find them? How do our users actually connect to our application?
Yeah, this is that whole ephemeral thing coming back to create a new challenge for us. Every single time a pod restarts, it gets a totally new IP address, so you can't just point to one address and call it a day. So how on earth does Kubernetes solve this huge networking puzzle? Well, it gives us two amazing tools. First up is the service. A service is like giving a whole group of pods a single permanent mailing address. The individual apartments might change, but the building's address always stays the same. That's a service. Then, for more complex web traffic, we have the ingress. An ingress is like a super smart traffic cop at the main entrance to our city. It looks at where the traffic wants to go and directs it to the right building. All traffic for api.myapp.com, go to building A. All traffic for myapp.com/blog, okay, you go to building B. So our app is running, it's self-healing, people can find it, we're almost there. But apps need more than just code. They need configuration data, like which database to talk to, and they need sensitive data, like passwords and API keys. How do we handle that stuff safely? Kubernetes gives us two simple objects for this. For anything that isn't a secret, like a database URL or a list of features to turn on, you use a config map. It's just a simple map of key value pairs. But for the really sensitive stuff, the passwords, the API tokens, that has to go into a secret. This is a huge best practice because it separates your configuration and your secrets from your actual application code, making everything way more secure and flexible. But, and this is a really, really big but, you have to listen to this piece of advice. By default, a Kubernetes secret is only base 64 encoded. That is not encryption. It's like folding a piece of paper in half instead of putting it in a locked safe. Anyone who can get to the raw data of your cluster can easily decode it. So for any real-world production system, you absolutely must enable encryption for your cluster's data store. Seriously. Okay, so let's do a quick flyover of our Kubernetes city one last time. The whole city is the cluster. It's made up of buildings, which are the worker nodes. Inside those buildings are the apartments, our pods, where the apps live. We use a deployment, our trusty property manager, to make sure those pods are always running. We use a service to give them a stable address and an ingress to act as a smart traffic cop. We manage our data with config maps and our sensitive data with secrets. And the whole city's blueprint is stored safely in etcd, City Hall's unbreakable book of records. Look, Kubernetes has totally changed the game for how we build and run software. It gives you the power to build systems that are more resilient, more scalable, and more secure than ever before. It's an incredible tool. So the real question is, now that you know how it works, what are you going to build with it? The sky's the limit.